Q. What do you understand by expanding universe hypothesis? How did Big Bang result in the formation of galaxies and stars? 250 words NCERT Physical Geography Class XI, page 14 and 15. Key demand of the question. The question expects us to explain our understanding of Big Bang theory and how the universe came into being. Thereafter, it expects us to explain how galaxies and stars came into being. Structure of the answer. Introduction. Explain that after long debates and multiple theories, scientists have come to believe that universe as we know it today was formed 13.6 billion years ago as a result of Big Bang theory. Body. Explain what Big Bang theory is and how it resulted in the creation of universe as we know it today. Thereafter, discuss how galaxies and stars came into being. Expanding universe hypothesis. Big Bang theory is also called expanding universe hypothesis. Edwin Hubble, in 1920, provided evidence that the universe is expanding. Big Bang theory is the leading explanation about how the universe began. At its simplest, it says the universe as we know it started with a small singularity, then inflated over the next 13.8 billion years to the cosmos that we know today. As time passes, galaxies move further and further apart. Similarly, the distance between the galaxies is also found to be increasing, and thereby, the universe is considered to be expanding. The Big Bang theory considers the following stages in the development of the universe in the formation of galaxies and stars. In the beginning, all matter forming the universe existed in one place in the form of a tiny ball singular atom with an unimaginably small volume, infinite temperature, and infinite density. At the Big Bang, the tiny ball exploded violently. This led to a huge expansion. It is now generally accepted that the event of Big Bang took place 13.7 billion years before the present. The expansion continues even to the present day. As it grew, some energy was converted into matter. There was particularly rapid expansion within fractions of a second after the Bang. Thereafter, the expansion has slowed down. Within 300,000 years from the Big Bang, temperature dropped to 500 Kelvin and gave rise to atomic matter. The universe became transparent. The expansion of universe means increase in space between the galaxies. The distribution of matter and energy was not even in the early universe. These initial density differences gave rise to differences in gravitational forces, and it caused matter to get drawn together. These formed the basis for development of galaxies. The galaxy contains a large number of stars. Galaxies are spread over vast distances that are measured in thousands of light years. The galaxy starts to form by accumulation of hydrogen gas in the form of a very large cloud called nebula. Eventually, growing nebula develops localized clumps of gas. These clumps continue to grow into even denser gaseous bodies, giving rise to formation of stars. The formation of stars is believed to have taken place some 5 to 6 billion years ago. www.insightsanindia.com 51 www.insightsays.com. Secure synopsis. Q explained the three major groups of rocks along with their subtypes which are found in Earth's lithosphere. 250 words. GC Leon. CH2. Earth crust. Key demand of the question. The question is straightforward in its demand. It expects us to explain the major categories of rocks along with their subtypes. We need to explain the formation, origin, characteristics and subtypes of these rocks. Structure of the answer. Introduction. Explains that Earth is made up of different types of rocks, each different from the other. Body. Explain the origin, formation and characteristics of igneous rocks along with its subtypes, plutonic and volcanic, sedimentary rocks and its subtypes, mechanically, organically and chemically formed sedimentary rocks and metamorphic rocks. Give examples for each. Background. Major groups of rocks found in Earth's lithosphere. All the three types of rock, namely igneous, sedimentary and metamorphic, make up the Earth's lithosphere, the outermost layer. The lithosphere is solid rock. Sedimentary rocks are the most abundant rock only on the surface of the Earth, but igneous and metamorphic are abundant deeper into the mantle. www.insightsanindia.com 52 www.insightsays.com. Secure synopsis. Igneous rocks. Igneous rocks come in many varieties. However, all igneous rocks began as molten rock magma which cooled and crystallized into minerals. Igneous rocks form when molten rock magma or lava cools and solidifies. Igneous rocks may look different because of two factors. They may have cooled at different rates, and the mother magma, original melted rock, was of a different composition. Variations in these two factors have created many different types of igneous rocks. When the magma cools at different rates, it creates different sized minerals. Quick cooling magmas have small minerals with the exception of obsidian, which is actually composed of silica, but has no crystalline structure. Basalt, for example, has small minerals, most of which can only be seen under a microscope. Magma that cools slowly creates rocks like granite, which have large minerals that can be seen with the naked eye. When lava cools very quickly, no crystals form and the rock looks shiny and glass-like. Sometimes gas bubbles are trapped in the rock during the cooling process, leaving tiny holes and spaces in the rock. Examples of this rock type include basalt and obsidian. Sedimentary rocks. Sedimentary rocks originate when particles settle out of water or air, or by precipitation of minerals from water. They accumulate in layers. Generally, sedimentary rock is fairly soft and may break apart or crumble easily. However, sedimentary rocks may also form in dry, desert environments or in association with glaciers. For main processes lithic sedimentary rock, cementation, large solid sediments are then bound together by substances like silica, iron oxide, and calcium carbonate. Compression and compaction, fine sediments are compacted together as overlying sediments and water increase the pressure above them. Chemical action, dissolved minerals in water may precipitate out of water, or may be left behind as a result of evaporation. Biological processes, many forms of aquatic life like clams, coral, and diatoms dive and settle to the bottom of the water. Over time they can accumulate and become compressed into a solid mass. Examples of this rock type include conglomerate and limestone. Metamorphic rocks are igneous, sedimentary, or pre-existing metamorphic rocks that have been changed by great pressures and temperatures within the crust and upper mantle of the earth. Metamorphic rocks result when existing rocks are changed by heat, pressure, or reactive fluids, such as hot, mineral-laden water. Through crystallization, as a result of intense heat and pressure, many rocks will form new crystals without actually melting. Foliation. This is a layered arrangement of crystals in metamorphic rocks. The more intense the heat and pressure, the thicker the foliation. Distorted structure. Many metamorphic rocks display the curving or folding of foliation as a result of exposure to intense pressures. Increased density. Metamorphized rocks often have a higher density as a result of being exposed to extreme pressures. Contact metamorphism. When magma intrusive rock comes into contact with rock beneath the Earth's surface, the heat metamorphizes the surrounding rocks. www.insightsindia.com 53 www.insightsis.com. Secure synopsis. The temperatures were not enough to melt the rock, otherwise, an igneous rock would have formed. The rocks that result from these processes often have ribbon-like layers and may have shiny crystals formed by minerals growing slowly over time on their surface. Examples of this rock type include gneiss and marble. Q explain the various landforms created by the island glaciation. 250 words NCERB Class XI Physical Geography CH6, page 48. Key demand of the question. The question expects us to explain the landforms created by erosion and deposition as a result of island glaciation. In our explanation, we need to mention how such landforms are formed and the features of such landforms. Structure of the answer. Introduction. Mention that glaciation gives rise to erosional features in the highlands and depositional features in the lowlands. Mention that glacier plays a combined role of erosion, deposition, and transportation throughout its course. Body. Explain erosional features in the highland like quarry, pyramidal peaks, glacial through, hanging valleys, rock basins, moraines, etc. Background. Glaciation generally gives rise to erosional features in the highlands and depositional features on lowlands. It erodes its valleys by two processes: this plucking and abrasion. Plucking glacier freezes the joints and beds of underlying rocks, tears out individual blocks and drags them away. Abrasion. Glacier scratches, scrapes, polishes, and scours the valley floor with the debris frozen into it. Characteristic features of island glaciation: quarry, Third, follow basin cut into a mountain ridge. It has steep-sided slope on 3 sides, an open end on one side and a flat bottom. www.insightsanindia.com 54 www.insightsays.com. Secure synopsis. When the ice melts, the cirque may develop into a tar lake. Arates and pyramidal peaks, steep-sided, sharp-tipped summit with the glacial activity cutting into it from tube is called arate. When 3 or more cirques cut back together, recession will form an angular horn or pyramidal peak bergschrund at the head of a glacier, where it begins to leave the snowfield of Ikoria. A deep vertical crack opens up called the bergschrund. This happens in summer when, although the ice continues to move out of Ikoria, there is no new snow to replace it. In some cases not one but several such cracks occurred, which present a major obstacle to climbers further down, where the glacier negotiates a bend or precipitous slope. More crevasses or cracks are formed. U-shaped glacial troughs and ribbon lakes. Original stream cut valley, further modified by glacial action. It is a U-shaped valley. It is a mature stage of valley formation. Since glacial mass is heavy and slow-moving, erosional activity is uniform, horizontally as well as vertically. A steep-sided and flat-bottomed valley results, which has a U-shaped profile. After the disappearance of the ice, the deep sections of these long, narrow glacial troughs may be filled with wadi-forming ribbon lakes, also known as through lakes or finger lakes. Hanging valleys formed when smaller tributaries are unable to cut as deeply as bigger ones and remain hanging at higher levels than the main valley as discordant tributaries. The valley carved out by a small tributary glacier that joins with a valley carved out by a much larger glacier. Rock basins and rock steps. A glacier erodes and excavates the bed rock in an irregular manner. The unequal excavation gives rise to many rock basins later filled by lakes in valley through where a tributary valley joins the main valley. The additional weight of ice in the main valley cuts deeper into the valley floor and deepest at the point of convergence, forming rock steps. A series of such rock steps may also be formed due to different degrees of resistance to glacial erosion of the bedrocks. Moraines are made up of the pieces of rock that are shattered by frost action, embedded in the glaciers and brought down the valley. Those that fall on the sides of the glacier form lateral moraines. When two glaciers converge, their inside lateral moraines unite to form a medial moraine. The rock fragments, which are dragged along beneath the frozen ice, are dropped when the glacier melts and spread across the floor of the valley as ground moraine. The glacier eventually melts on reaching the foot of the valley, and the pile of transported materials left behind and the snout is terminal moraine or end moraine. The deposition of end moraines may be in several succeeding waves, as the ice may melt back by stages so that a series of recessional moraines are formed. www.insightsanindia.com 55 www.insightsays.com. Secure synopsis. Fjord. If the glacier flows right down to the sea, it drops its load of moraine in the sea. If sections break off as icebergs, moraine material will only be dropped when they melt, where the lower end of the trough is drowned by the sea. It forms a deep, steep side inlet called a fjord, typical of Norway and Chilean coast. Q. Among the various factors that contributed to Kerala floods, dam management has had a major role to play. Examine 250 words live into quite this question. The article discusses the various reasons for the severity of Kerala floods and a role that dam mismanagement played in accentuating the crisis in Kerala. Understanding the issues related to dam management in Kerala can be extrapolated to other states. The question is thus important for geography section of paper 1. Key demand of the question. The question expects us to underline in brief the various causes why floods in Kerala were so severe. Thereafter, we need to delve deeper into the issue of dam management, the lacunae in our policy, suggestions made by several committees, and the way forward. Directive word examine. When you are asked to examine, you have to probe deeper into the topic, get into details, and find out the causes or implications, if any. Structure of the answer. Introduction. Emphasize on the severity of rainfall battering Kerala state. Body. Explain in brief the various factors that enhance the severity of floods in Kerala. Explain the issue of dam mismanagement in detail, the associated reasons that it happens, etc. Explain the views of several committees formed which held that mindless construction of dams leads to several issues like earthquakes, etc. Conclusion. Summarize the lacuna in our policy and discuss the way forward. Background. Recently incessant rains in the past couple of weeks has caused massive flooding across Kerala. Reason for flooding in Kerala: more than average rainfall. India's western coast has received above average rainfall on account of sustained low pressure conditions. Land use. Injudicious use of land is responsible for making some regions of the state more prone to floods and landslides. However, other factors such as a change in land use patterns and climate change could have contributed to the situation on the ground. Incursions into catchment areas of rivers that have dried up and mountainous areas have rendered settlements in their vicinity vulnerable to the vagaries of nature. Kerala is yet to implement recommendations of the Gadgil Committee on Conservation of Western Ghats. The state is an exception that it does not have a single battalion of SDRF task force, which is mandatory as per rules to tackle natural calamities. www.insightsanindia.com 56 www.insightsays.com. Secure synopsis. India's Central Water Commission has also been under fire for failing to introduce a flood forecasting system to issue warnings. Climate change and global warming. Recent research indicates that rising temperatures have led to huge fluctuations in monsoon winds carrying the moisture from the Arabian Sea, resulting in heavy to extreme rains over the western Ghats and central India, lasting for 2 to 3 days. Deforestation. Unfettered development activity in the western Ghats had increased the chances of landslides, a major cause of casualties during the floods. Wetlands have been lost to development projects, construction of roads, and buildings at places too close to rivers. Dam Management. Kerala is home to 53 large dams with a collective capacity of nearly 7 trillion liters. As rain poured and rivers overflowed, these dams should have served as a bulwark. But for dams to truly tame floods, experts say dam reservoirs need to be relatively empty before the onset of rain. This was not the case in Kerala. When the downpours arrived in August, the near full capacity Idjwati was forced to release water into already flooded areas. Also, state did not gradually release water from about 30 dams in anticipation of rains. Local officials have been blamed for exacerbating the situation by failing to gradually open the dams dotting the state's complex river network, waiting instead until they were already full before unleashing the excess water. Interstate Dam Management. Like many dams in India, the Mullaperiyar is located in one state, Kerala, but operated by another, Tamil Nadu. Both state governments have been in constant conflict over the dam's water level in the current crisis. The Supreme Court had to intervene. CAT report. As per the 2017 CAT report, Kerala had not conducted a dam break analysis or prepared an emergency action plan. Neither has the state prepared the operation and maintenance and in manuals for any of its dams. The audit also observed that prescribed quality checks were not conducted by monitoring agencies in all 4 projects in Kerala. How to ensure such incidents don't happen in future? Reservoir operation and management need to be taken more seriously. Implementation of committee recommendations. Kerala should relook the Gadgil Committee and the Rankin Committee reports. It has put forth suggestions both reports and tried to reduce the area under ecologically sensitive zones, ESZs. It is time for it to re-evaluate its position regarding the SZs. The Gadgil Panel report calls for government intervention to curb activities such as quarrying, mining, land clearance or construction in ecologically sensitive zones such as those close to riverbanks, and violation of wetlands protection rules to need to be looked into. Kerala should set up a state flood commission to evolve a comprehensive approach to manage extreme rainfall in the state. This commission should examine the impact of major land use changes on the hydrology of the state. It should also look at the dam management systems. www.insightsanindia.com 57 www.insightsays.com. Secure synopsis. Besides this, district-level subcommissions should be set up to identify the areas where roads, railways, hydropower, embankments and other infrastructure projects aggravated flood problems and suggest mitigation measures. As a country, India needs to improve environmental governance while working with other countries to halt global warming. Flood control can be effected through an integrated dam management system, which is totally computerized and automated, the only exception being lifting and lowering of shutters, which has to be done manually. This system, which can be called IDMS, has to be evolved and developed independently. Integrated approach to managing floods requires a sound understanding of the patterns that rivers such as the Congo and its tributaries display during a monsoon. Governmental understanding of the problem generally relies not so much on advanced techniques such as mapping based on satellite imagery and geographic information systems, but on ground-level surveys and anecdotal reporting. This needs to change.